So hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 18 of the Geeks or Geeks problem of the day, and let's see what the question is. It's a medium level question. From the last 2 days, if I remember correctly, we only had easy level problems. This is the medium question after a long time. Okay, so yeah, this question is I will say, like, see, if you try to understand the concepts involved here, that's good, but don't feel like in a way like you are not able to solve this question, so you will not be able to clear it. Don't think like that. This is a very tricky question. If you know the trick, you can solve this. If you don't know the trick, no problem. Just learn the concept, and obviously always go through what is involved here. Okay, like here XOR is involved. Just try to understand what is XOR, what are the different scenarios, what are the different properties of XOR. Okay, if you understand that, that should be enough. For a fresher, this is what my suggestion will be. Let us get a deep dive into the question. Okay, so the question says that, first of all, see, there is a n given to us, and basically there is an array given to us. This n refers to the length of this array. Okay, and ultimately return the integer at the output. Okay, now coming to the question, given an array of size n, okay, the value of array is denoted by bitwise XOR of, see, they are defining this value of array. Okay, please understand this term. This whole question is also on that. Okay, ultimately we'll have to find the value of the given input array. Okay, so the value of an array is denoted by bitwise XOR of all elements it contains. Okay, bitwise XOR. What is a bit? Bit simply refers to, for example, if you take a byte, it has 8 bits. Okay, so similarly, uh, there are, you have to do it bitwise. Okay, we'll go through that also, but just understand, simple XOR and bitwise XOR has some differences. Okay, you have to do a bitwise XOR for all elements it contains. Okay, find the bitwise XOR of the value of all subarrays of A. Okay, find the bitwise XOR of values of all subarrays of A. Okay, so they have defined what a value is for array. Then they are saying, find the values for all the subarrays and do XOR of that. Okay, this is what the question is. Okay, what is the real life application of that? I don't see any real life application of this, but as I mentioned, this is a tricky question. You will not find a real life application of this. Okay, now coming to the thing, see, first of all, as I mentioned, subarrays is important. I hope you understand what a subarray is. Subarray simply means a contiguous part of array. Okay, a continuous part of array. For example, 2 and 3 is a subarray, but 1 and 3, okay, as you can see, 1 and 3 is not a subarray because that is not continuous. Okay, similarly, you start from this 3 and if you go to this one, this again not a subarray. Okay, because 3, with 3 the array ends, right? So as you can see, this forms some of the subarrays. All subarrays are listed here. Okay, first of all, what we have to do is we have to do a XOR within the subarray. Okay, for example, this one element here, always XOR of one element is the same element. Okay, remember this is again one property. Similarly for this, and XOR of two elements, I will tell you how to find it. It's again the same thing. Okay, and so on. Okay, so yeah, so you have to first do XOR of all the subarrays. Get the XOR for all the elements of the subarray. Get the answers here. For example, 131023 is the XOR of the subarrays. Then for these numbers which you have got, you have to again do XOR. Okay, so 131023 are the results of XOR of subarrays. Then you have to do a XOR of these things again. Okay, you have to do XOR of these things again, and you will get the answer as 2. So 2 is the final answer you have to return. Okay, so take a minute, pause the video here, just go through it again. I again repeat, this is not something which will be expected to solve in an interview or somewhere like that. Okay, it just, it's a kind of an idea involved. You just have to give your idea if it is asked in the interview. Okay, obviously the kind of trick that is involved here and the time of space and time conflict they're expecting, it cannot be expected from a fresher as a in interview, right? Let me make it very clear, right? It's a tricky question. If you know the trick, you can solve it. That's it. So yeah, now coming to what can be done here is, we will try to see the brute force approach first. In the brute force approach, again same thing, right? If you know how to find all the subarrays of a given array, then again your 90% of the question is solved, and then we'll simply take the XORs and we'll return the answer. Okay. So let's see how that is done. In the next approach, I will also show you the optimized approach. Okay, what can be done. And as remember, optimized approach, I guess you can get it from many sources. Let me make it very clear and honest. You can get this answer from many sources, but in my video, I will explain you how this is coming. Okay, I've done a lot of work here, and I will explain you how this works. Okay, so let's go for the brute force approach first. So in the brute force approach, uh, I've declared answer variable which will be my final answer. Initially, it is 0. Okay, so how to do this? Okay, first, my as I mentioned, the 90% of the question for the Bruce approach deals with how to find the subarrays. Okay, so what I'm doing is, see, first loop, this is the variable I, revolves from each number. Okay, I will be 0 to n minus 1. Okay, similarly for j is not like same as that of I. J will start from I and it will go till n. Okay, what that means is, try to understand here. In the first loop, what are the elements we'll capture here? See, in the first loop, always one will capture, right? Because I, this in this case I is 0, right? I is equal to 0. I am talking about this array, okay? In this case I equal to 0, so this is the first element that I will capture. Now this loop will start, okay? The inner loop will start. This will start from where the I is till the last element of the array, okay? It will keep including the next element. So in the first loop, the next element which will get is this. In the next loop, in the same loop, which the next element which will get is this, okay? 1, 2, and 3. So all of them you can see are going to start with 1, okay? Now come to the second loop, okay? The second element is 2. Again, every subarray that starts from 2 will be listed in the second loop. Similarly, 3, every subarray that starts with 3 will be listed in the third loop, and so on. Okay, so this first loop refers to all the subarrays that start with the first element. Second loop refers to all the elements, so all the subarrays that start with the second element, and so on. Okay, this is what is happening. And now comes the technical part: how to take the XOR. So for each inner, that is for each outer loop, I am declaring a variable here, subarray XOR equal to 0. Okay, so when the first element comes, I will take a XOR of it with the existing. That is initially it is 0. Okay, I will take XOR of it with the first element. I will save it here. Once I have that, I will do again XOR with my original answer. Why we are doing this thing? See, this part is very important. Remember, as you can see, initially I have 1. Okay, in the first loop, in the first instant of the inner loop, I have 1. Okay, see, this is the first loop of the see, what I've mentioned here is first outer loop. I should have written, okay, the first outer loop. For the first outer loop, this is the value for the first inner loop. This is the value for the second inner loop, and so on. Okay, this is the value for the third inner loop. Okay, so what I have to do is, see, I have to take for 1 separately. I have to take for 1 and 2 separately. I have to take for 1, 2, and 3 separately. Okay, and then I have to XOR all of them with the answer. Okay, so that's why we are doing this. See, this ensures that all the XORs are made. Okay, for example, XOR of 1 is 1, XOR of 1 and 2 is 3. How we are getting that also I will tell you. XOR 1, 2, and 3 is 0. So each of them should be XORed ultimately. Okay, 1, this is the 1 and 3, and this is the 0. This should also XOR with in the final answer. Okay, this is what we are ensuring through this. This is what we're ensuring through this. Okay, for each subarray, whatever value you got for that subarray XOR, you have to do it XOR of that again with the final answer. Okay, the final answer which you are getting. That's what we are doing. This yeah, I hope you would have understood by this tracing what is happening. So this basically refers to the inner loops. Okay, the 3 inner loops for the first outer loop, the 2 inner loops for the second outer loop, and the 1 inner loop for the third outer loop. Okay, you'll get this kind of arrays, and for this thing will be captured. Okay, initially this value will be 0. In the first loop it will become 1. In the second, while we are doing this, it will become a subarray of XOR of these two, and similarly it will go for these 3. And while we are doing XOR with the this is the XOR operator, by the way. I hope you will be knowing this. If you are very new, then let me tell you, this is XOR operator. How we are doing XOR? Okay, let me go for that also. Yeah. Okay, what XOR basically means is that, for example, they have mentioned here that the XOR of 2 and 3 is 1. Okay, how we are getting that? Let me tell you that. Okay, so first of all, I have to represent 2 in the bitwise way. Okay, you have to represent 2 in the bitwise way. What is the that of? Okay, this is 2. How it is written in the bitwise way. Okay, for example, this is the 2 raised to power 0. This 2 raised to power 1. Okay, that's how 2 is written. Okay, now coming to what they have mentioned, 2 and 3, right? Okay, 2 and 3. So what is 3 now? For 3, basically it is 2 plus 1, right? It's 2 plus 1, so it will be 0, 0, 1 comma 1. Okay, why? 2 raised to power 0 is 1, right? This will be taken 1. 2 raised to power 2 raised to power 0 is 1. 2 raised to power 1 is 2. So 2 raised to power 1 plus 2 raised to power 0 equals to 3. Okay, that's how it is made. Now I have to do XOR. What is XOR basically? I will just write below that and show you. For each of these, okay, suppose uh, see, if the values are same, it will be 0. If the values are different, it will be 1. As simple as that. So to compare this element and this element, okay, you can clearly see the values are different. Okay, so what will be the answer? It will be 1. In this case, this is also 1, this is also 1. Okay, when the values are same, what will the XOR of that? It will be 0. Okay, it will be 0. Now come to this. Okay, values are same, this and this are same, right? So what will be the XOR here? In this case, it will be again 0. Okay, now similarly for the last case, this is also 0 and this is also 0. So what with XOR, it will be again 0. So now you get some number here. Okay, so what is this number? This basically refers to 1. Okay, this basically refers to 1. So if you see here, what is the XOR of 2 and 3? It is 1 basically. That's how you are getting it. Okay, so this is all about it. If you want, I can like give you this in the comments. But remember, you will have to do some homework. Okay? You cannot simply rely. See, I'm expecting you to know something, right? if you don't know, please go before you see. Once you see XOR here, you will have to open your Google search and search what is XOR, what is bitwise XOR, what is the difference between them, and Python how to execute them. Okay, so I hope you will do that. So this was all about the brute force approach. Now coming to the the yeah the optimized approach. So what it does, that is okay. You can go through it once, but what I will just give you a gist of what is happening, and then we'll see how this answer we have reached. Okay, so it's clearly simple. If the number which you are getting, that is the length of the array. If the length of the array is an even number, simply return zero is the answer. Okay, as simple as that. If it is not even, then we will do some calculations. What is the calculation? We will take only those numbers, that is only those positions in the real array which are in the, suppose for example I is the index. Suppose the index is even number, only those numbers we will take and we'll do XOR of that in the final answer. For example, uh, if you can see this case, we'll do XOR of only 1 and 3. Okay, we'll do XOR of only 1 and 3, and that will give us the final answer, as simple as that. Okay, so that is what is happening here, and then we are getting the answer. How we are doing that, let me quickly show you. I've prepared something here. I hope you will find this useful. Okay, let me zoom in. So first of all, we'll take a case where the number is even. Okay, and when n is 6, that is the when the array given to us has the length of 6. That means it is even, right? So let us see what are the various possible subarrays. Okay, so I have listed all the possible subarrays. Okay, you can check it for yourself, but you will get the same thing. Okay, these are all the possible subarrays. Okay, this is the one where the length of subarray is 1. This is the one where the length of subarray is 2, and this is where the length of subarray is 3, and so on. Okay, so just check it for yourself. You will get the same. Okay. Now try to understand here. Remember, there is one property of XOR. If you XOR a number with itself, for example, let us say k is a number. Okay, if I do a XOR of k, okay, with itself, if I do XOR of k with itself, I will always get 0. Okay. Now try to understand this. If I do XOR of k with itself for 3 times, I will again get k. So this property resolves. Okay, how many times we are doing XOR with it? For example, if I do it for a 4th time, this again becomes 0. Okay, and so on. That means if you do XOR of a number with itself for even number of times, we'll get 0. If we do for odd number of times, we'll get the same number. Okay, this is the idea which we are going to use now. Okay, now please try to calculate how many times a is present here. Okay, how many times a is present here. If you simply calculate, see, for example, this is a present. Okay, let me do it for one thing, then you can do for the rest. So this is the first time a is present, second time, okay, third time, fourth time, fifth time, and sixth time. That means A is present for 6 times. Okay, that is the even number. That means A is totally ruled out. A is not going to contribute anything for the final answer. Now coming to B, I see I cannot do it for everything, but I have just listed out the results. You can check it for yourself. Okay, let me do it for B again. The only thing which you have to see is that if they're even or odd numbers. As I mentioned, if the number is even, then it's the, for example, in this case, D is 12. Okay, this was 12 times. That means it's an even number, right? So D is not going to contribute anything for the final answer. As simple as that. So I'll show you how I'm getting for C. Okay, I will just quickly show you. So first time, okay. So yeah, first time, second time, third time, okay, fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, 10th time, 11th time, and 12th time. Okay, so these C is present for 12 times. You can check for the rest of that. You can see that for each number in this array. Okay, for each number in this array, each of them has present for even number of times. That means each one of them is not going to contribute anything for the answer. That means the answer is going to be 0. That is what is the logic which we are using here. See, I have done it for n equal to 6. You can trace for any even number. Okay, for example, n equal to 2, n equal to 4, anything you can do. I've taken a slightly bigger number to show you that even it works. Okay, so that is the basic idea. That's why we are doing this. If the length of the array is even, okay, that is even number of elements are present in the array, then the answer is going to be 0, because none of them are going to contribute anything for the answer. Okay, now let us come to a part where, yeah, this part. Now let us talk about n equal to 5. Okay, so if you see for n equal to 5, yeah, n equal to 5, you will see the same thing I've done. I've listed out all the possible subarrays here. Okay, all the possible subarrays here, and again I will listed out their counts for each of the elements. Okay, for each of the elements. I hope this is visible to you. Okay, I'm trying my best to like make it as much zoom as possible. Okay, so this is the array given to us. It has a length of 5, as I mentioned here, and again I'm trying to find all the possible subarrays here, and then I'm listing for each element how many times it is present in each, and any subarray. Okay, for example, if I talk about A, you can see A is present in the starting always, and it is for 5 times. Okay, 1, 2, 3, 4, 5. A is present for 5 times. Again, I will show you for one of them which is in the middle. Again, I will let us see for C. I will show you again. Okay, so C is the first time. Okay, second time, third time. Okay, fourth time, fifth time, okay, sixth time, seventh time, eighth time, and ninth time. Okay, that means C is present for 9 times. Okay, and for the rest of them also I've shown. You can just calculate for on your own. Okay, I will give this part in the comments also, so that you can refer. Okay, so one thing that you will notice here is that, see here, all of them are coming as even, but when the n equal to 5, that is when we are taking a array of odd length, you know, not everything is coming as even, right? What is not coming as even? See, the first element is that the zeroth index is not coming as even. The second index is not coming as even. The third, that is the fourth index is not coming in even. So if I try to, that means try to understand, B and D are not going to contribute anything for the answer. Okay, B and D are not going to contribute anything for the answer. So what that means is that any number which is present in the index which is not divisible by 2 is not going to contribute for the answer. For example, here B is present, okay, in the index 1, it is not going to contribute for the answer. Here D is present, okay, in the index 0, 1, 2, 3, and so yeah, in the index 3, so it is not going to contribute anything for the answer. That means only A, C, and E are going to contribute for the answer. Okay, as I mentioned, A is coming up 5 times, it's an odd number of times. That means the XOR of A with itself will never be, 0. Similarly, C is going to contribute, and similarly E is going to contribute. Okay, so if you have to get the final answer in this case, you can simply do that. Answer is equal to XOR of A with XOR of C with XOR of E. Okay, this is the final answer in this case. Okay, sorry, yeah, the XOR. Okay, so this is the final answer in this case. Okay, this is the final answer. And if you talk about this case, that is the even case. In this case, the answer is going to be 0. Okay, because none of them are going to include for the answer. Yeah. So I hope this thing is clear to you. So that's why we are doing here. If you see, yeah, that's why if the number is even, simply return 0. If the number is odd, so what are the various things which we have to see? If the number is odd, only those indexes which are divisible by 2 are only going to contribute for the answer. So we are only checking if the index is divisible by 2. If it is divisible by 2, only then take XOR of it with the real answer, which is initialized with 0. Okay, just do it with that only one time and simply return the answer. I can run and show you this works. And also you can segment and see it works. Okay, and if you talk about the Rufus approach, I will just run and show you. It also works. I've taken a different base case. This will not be your base case, I guess. I've taken a different base case, and you can see it also works. Okay. So this was the basic idea behind why it, see, this is again, as I said, it's you have to dig in fast. Okay, in an interview, if it comes, okay, if it comes, what you have to do is first of all start using the brute force approach. Then you will have to do, devise these things. Okay, the interval will give you hint that see, the interval itself will ask you to derive what are subarrays, what are the final things which are going to contribute for it. You have to derive those things. If once you derive these two cases, then maybe I guess the interval will give you hint that what is going to convert for the answers, and maybe then you will have to code it. Okay, uh, so if you're a fresher, I will say that don't think that simply we'll have to code it in the interview if it comes. Not like that. The interval will give you hints. The interval will try its best to give you the direction of so that your thinking is reaching in this place. Okay, so that you will able to think that what if the length is even, what you have to do. If the length is odd, what you have to do. And if the length is odd, what indexes to consider. Okay, what not to consider. So I hope you would have enjoyed this video. If you like my friends, please subscribe to my channel. For every day, we are solving it and we are giving you the answer. And remember, the answer is not important. The thinking behind it is important, because that is what is tested in the interview. You may clear the online assessment, but in the interview, your thinking will be tested. Okay, if you're not able to think properly, if you're not able to give logical explanation for your thinking, then let me tell you, you will not be selected for that. Okay, for the next rounds. So I hope you like my video. Please subscribe to my channel. And yeah, we'll see you tomorrow. Thanks a lot.